Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. I bid to Madam Azwin. Our group would like to present about equilibrium of rigid body. Our group consists of 5 members, which is me, Amir Haikal, Melanie, Muhammad Ismail, Akmal Razi Azani, and Miguel. Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. Alright, I will start with the introductions. The equilibrium is a state of body where neither the internal energy nor the motion of the body changes with respect to time. Let us to try to understand the equilibrium of rigid body. If we have to define equilibrium, the simplest definition would be it is a point where the net internal force as well as torque acting on the body about or any other point is zero. But to be more specific, for a rigid body equilibrium means both rotational and translational equilibrium. Okay, alright, I will start with the introductions. The equilibrium in our equilibrium of rigid body, we choose the type of support which is pin or hinge. A pin support allows to rotation about any axis but prevent movement in the horizontal and vertical directions. For example, door hinges and also the crankshaft in an engine and so on. Next, I will pass my presentation to our next presenter.
The next part of the presentation is the type of connection, which is the difference between a hinge and a pin connection. The difference lies in the number of bolts that we usually find in the connection, which in turn infers the ability of the connection to rotate. The first one is the pin connection. It needs to be able to rotate, so it will only be able to have a single bolt to provide the material for the shear transfer. A pin connection works essentially like a lap joint. It transfers vertical and horizontal shear loads and cannot resist any bending or moment rotational forces. The amount of load to be transferred through the joint will determine the size of the bolt and the plate thickness. The next picture is a base connection, which is a pin connection. It has only one bolt going through a lap type connection. Therefore, it can permit rotation. Next, it is a hinge connection. A hinge connection will have a greater number of bolts in order to resist the shear force. It will not be able to rotate as a result of the bolts, but it is still intended to resist any bending moment. A hinge connection is rather a large category of frame connections that include many types are either not intended to rotate or not designed to resist rotation. Vertical and horizontal forces are transferred through these joints. The next picture to it is the connection of the gray plate to the blue beam constitutes a hinge connection. It is essentially using bolting to transfer vertical and horizontal through the connection. The next part of the presentation is the type of
So I'm gonna talk about the free body diagram of reaction. In structural engineering, pin and hinge support are both types of structural connection that allow for rotation of the connecting members. However, a hinge support also allows for some translation while the pin support does not. When analyzing the forces acting on the pin and hinge supports, a free body diagram can be used. A free body diagram is a graphical representation of all the forces acting on an object, in this case, the pin or hinge supports. In the case of the pin or hinge support, the free body diagram will typically show three forces acting on the support: a vertical force, a horizontal force, and a momentum. The vertical force is equal to the weight of the structure supported by the pin or hinge acting downwards, while the horizontal force is usually zero for the pin support, but for a hinge support there may be a horizontal force if there's some horizontal movement allowed. Finally, the moment is a twisting force caused by the weight of the structure acting on the support, which causes it to rotate. For a hinge support, there may also be a horizontal reaction force and a vertical reaction force acting on the support, which arise due to the translation allowed by the pin. These forces are typically shown in the free body diagram as well. And this we can see on the next slide. So, so right here in the first image, we can see the single smooth pin and the single hinge with all of its forces, all the forces that act upon them. We can see the vertical forces and the horizontal forces and also the momentum. In the second image, this is a sketch of an exercise that I brought the free body diagram of it. We can see that the free body diagram represents all the forces that act upon the hinge. The horizontal forces, the two vertical forces, and the two tensions. And that's it. This is all of my part. I will pass to the next presenter. So, right here in the first
Okay, now I will talk about the unknown of the pin or hinge support reaction. The first unknown is the force magnitude. In such circumstances, it is possible to not know the exact value operating on the pin or hinge. Depending on the structures making up and the force exerted on it, this force may be tension or compression force. Calculated using equilibrium or dynamic principles are required to calculate the unknown force magnitude at the hinge or pinch. The second unknown force is the force of direction. A pin or hinge may experience forces that are unknown in both their magnitude and their direction. This implies that the exact direction of force travel through the structures, whether it is operating in tension or compression, may not be immediately appear. For a precise analysis of the structure equilibrium or dynamic behavior, it is essential to identify the appropriate direction. Force direction. Engineers and physics employ the concept of static or dynamic to discover the unknowns. By calculating the total of the force and moment acting on the structure, equilibrium equation for the unknown force magnitude and orientation may be constructed. Equations of motion are used in dynamic analysis to compute the response at pin or hinge depending on the structure's dynamic behavior. It is significant to note that the precise number and kind of unknown might change based on the difficulty of the issue and the precise requirement provided. Additionally, when the problem is further restricted or new information is revealed, the unknown may alter.
Alright, thank you to the current presenter. Now I will take my part to present about uh, examples related to the pin or hinge supports. Alright, so the first example that I choose is a swinging fence. Basically, the gate consists of a solid panel which is attached to a vertical post. It is to enable the gate to swing open and close where it is a hinge mechanism is used. The hinge is typically composed of two metal plates, which one attached to the gate panel and the other attached to the vertical post. These plates are connected by a pin that acts as the pivot point, and the metal plates and pin used in the hinge mechanism are typically designed to be sturdy and durable. They should withstand the weight of the gate and withstand regular use over time without breaking or bending the gate. So, the pin is inserted through holes in the plates, allowing the gate to rotate around it. Next, when the gate is closed, the weight of the gate panel is supported by the hinge mechanism. The hinge pin provides stability and also prevents the gate from sagging or falling down. It also allows the gate to swing open smoothly when it is needed, even when there are external force acts on it, for example, like wind or pressure. So, in this example, the hinge and pin combination acts as a support system for the gate, which is it enabling it to function properly. It bears the weight of the gate and also facilitates the movement and ensure that the gate remains secure when it is closed or open. Alright, thank you to the current. Alright, so done with the first example. Now we move on to the second example, which is I have choose. Basically, it is a folding chest, which is related to the hinge or pin system supports. Alright, first thing first, folding chests incorporate hinges that enable the chair to fold and unfold easily. These hinges are usually located at the points where the seat and backrest meet the chair's frame. It is they allow the seat and backrest to pivot, enabling the folding action. In addition to the hinges, folding chairs utilize locking mechanisms to secure the chair in its open positions. Basically, these mechanisms often consist of pins, clamps, or latches that engage with corresponding receivers on the chest frame by preventing it from collapsing unintentionally. So basically, the hinge and locking mechanisms work in tandem to provide supports and stability when the chair is in use. So the hinges enable the chair to maintain its structural integrity while the locking mechanisms ensure that it remains securely in the open position by preventing it from accidental folding. Alright. When it comes to the folding chairs, the hinge and locking mechanism basically play a crucial role in achieving compact storage. So, by releasing the locking mechanism and folding the chair along the hinges, it can be efficiently stored or transported by occupying minimal space. So, the hinge and locking mechanisms in folding chairs are designed to withstand repeated folding and unfolding without compromising their functionality. And also, they are typically construct from durable materials by ensuring that the chair remains steady and also reliable over time. So, the combination of hinge and locking mechanism in folding chairs makes them user friendly. Users can easily fold or unfold and the chairs by manipulating the hinges and engaging or disengaging the locking mechanism. So, I think that's all from us. Thank you. Oops, hold up. These are some quotes for you guys. Let's go to UTP and study statics and dynamics together with our classmates happily. So, bye bye. Thank you. Oops, hold up.